Okay, taking chances for fun and profit. Salkind starts out this chapter stating, so you want to be a scientist. You may be saying to yourself, hey, I never signed up to be a scientist. But think for a moment what a scientist does. Systematically observes, develops theories, formulates hypotheses, creates experiments, and judges the results. Social workers, they systematically observe, develop theories, formulate educated guesses, develop interventions, and assess those interventions. Just like social work is more of an applied discipline of study, the science we do is more of an applied science. In Chapter 7, we discover the difference between a sample and the population, which will be important in helping us determine what kind of statistical tests we need to use with our interventions. We will revisit the concept of the Null Hypothesis and how it relates to the research hypothesis, and then finally how to tell a good hypothesis from a real stinker. I don't know why everybody seems to hate science. I mean, really, what is wrong with a discipline where it is okay to make guesses? Seriously though, while some individual scientists seem like they want to be Mr. Know-it-all, science as a discipline is always a tentative game. Good scientists and good researchers will often respond to direct questions with terms like, well, the best guess we have based on the available evidence, etc. When we think in tentative terms, what we don't know versus what we do know, it guides us to seek more knowledge. And when we get familiar with that area of a phenomenon that we don't know, it helps to drive the formulation of a new research question. Think about social work practice. Even the most strengths-oriented social work practitioner will be asking themselves questions about the gaps, the barriers, those things that prevent their clients from actualizing their greatest good. Even when we are doing something that seems completely unscientific, say for example, engaging with the thoughts and feelings of our clients in therapy, we will be relying on scientific method. The art of doing therapy is the art of simultaneously attending to all the auditory, visual, emotional, and other cues your client is providing, all the while engaging in a mental dialogue, much of which is a questioning process. For example, we may ask ourselves, why is it, despite the strong desire of this client to enter into a stable relationship, he consistently sabotages the relationship just as it moves into a more intimate place? Of course, you pull out your theories of intimacy and ask the next question. Maybe even formulate an idea that might help direct your client, and you assign them homework. When they come back the following week, you ask them, well, how did it go? You've just done therapy, and like it or not, you were just a scientist as well. Populations, in the scientific sense, is the large group to which you would like your findings to generalize, if possible. So, if you're interested in studying people as a pretty large group, about 7 billion the last I heard, I think we better narrow that down a little bit. Usually, we want to study a subset of people: U.S. citizens, Kansas City residents, people with schizophrenia, victims of childhood sexual abuse, etc. These are all populations, and in order to study them, we need to find some way to narrow down the list from the 3 million or so U.S. citizens to a manageable yet meaningful number. We narrow down the population to that more manageable and meaningful size through a process we call sampling. There are whole books written about sampling. Entire special editions of journals are dedicated to sampling. Individual articles are sometimes written about sampling with both general and special populations. It is beyond the ability of a basic social sciences statistics test to tell you what kind of sampling you need to do for your research. The good researcher will look to relevant literature for studies of populations similar to theirs, look carefully to the methods sections to see what other researchers have done. Then the good researcher will also look over the findings of each study to see how well their sampling frames worked for them. And finally, sampling is something that is very contextual. You must take into consideration the realities of your situation. Yes, it would be wonderful to have several thousand surveys returned so that your sampling error might be diminished. However, if you're working with a micropopulation, say gay, lesbian, bisexual, transgendered males with severe and persistent mental disorders, they do exist. I've worked with them right here in the heart of the good old US of A. Finding a sample of those folks is going to take a whole lot more work than, say, something like repeat DUI offenders. So your context will often drive a lot of elements of your research. Having taught research for a few years now, I've heard it all. Oh, Professor Prue, that Null Hypothesis is nothing more than a bunch of mental gymnastics. My response is, yes, and your point is? If you've ever seen a gymnast on television, say during the Olympics, you've probably thought or felt deep down inside that it would be fantastic to be able to do what they are doing. I know I have, but I also know that I've never had the discipline to do the exercises necessary to do gymnastics. I can't say that I've been a big fan of mental exercises either, but I do them when they are important. Just like I walk, ride my bike, go do yoga, etc., to do my physical exercises. Essentially, the null hypothesis is the recognition that before we have any evidence to the contrary, we are going to assume that two groups are equal. Makes sense? When we randomly select individuals into a control and an experimental group, or intervention group, we assume that those two groups are equal. If we are asking questions of survey data, say, frequency of unprotected sexual encounters by gender, we assume at the outset of our research that there is no difference between the two groups. When we make those assumptions, we set a benchmark or a known value against which we can compare the findings. Therefore, our null hypothesis enables us to statistically compare the two groups. So while we may hope that our intervention group improves at a faster rate than our control group, we can't say so with certainty until we've compared the outcomes. Slide 7. So while the null is something of a mental exercise, the research hypothesis is not. It is our statement based on theory what the relationship will be between two variables. Typically, with experimentation or quasi-experimentation of our social interventions, which are based on theory that our intervention groups will do better. So typically, with that type of research, we will make a directional research hypothesis. With survey research, it is not uncommon to make a non-directional research hypothesis. Let's go over each one of those. When we specify a non-directional research hypothesis, it is essentially saying that we are unsure about which way the change will happen or in which direction the difference between the two groups will trend. Say you want to test the difference between Meals on Wheels in its traditional form, where there is a not-for-profit kitchen somewhere that packages and delivers meals to homebound people, and private food delivery companies such as Pizza Hut, Jimmy John's, Domino's Pizza, plus a wide variety of independent ethnic restaurants that provide delivery. In order for us to measure if there is a difference, we have to specify an outcome or several. Let's say that our outcomes are meals accepted, meals eaten, and changes in weight. For our non-directional research, we would simply hypothesize that there will be a difference between the two groups. Now let's get some direction here in slide 9. When we make our research hypothesis directional, it simply means that we have some theory about which way the change will trend. Let's stay with our Meals on Wheels example. We could come up with multiple theories for each of the outcomes we specified earlier and predict that one group or another would trend differently. For meals accepted, let us say that we are very familiar with the policies and procedures of the Meals on Wheels group, and we know that they have a very structured delivery schedule. Therefore, they will receive their food when it is convenient for Meals on Wheels to deliver it. That may sound harsh, but it is true. Say Mrs. Jones is an early riser and would like to have her prepared lunch from Meals on Wheels arrive at about 10:30, and Mr. Smith is a slug-a-bug, and he stays in under the covers until 11. If they are neighbors and the Meals on Wheels is delivering to Mrs. Jones by 10:30, they're probably not going to be able to deliver to Mr. Smith, who hasn't gotten out of bed yet. Now let's say instead of Meals on Wheels having a delivery truck, they simply have a dispatcher who calls Mrs. Jones and Mr. Smith to find out what and when they would like to have for lunch. Mrs. Jones feels like Chinese today, and Mr. Smith would like Jimmy John's, a Jimmy John's sub, but not until about 3:30, since he's a late riser, and he would like to get it hot. So the dispatcher places the order with the nearby Chinese restaurant, and Mrs. Jones gets her Kung Pao chicken about 11 o'clock and schedules Jimmy John's to deliver a meatball sub at 3:30 p.m. Which would be more likely to be accepted? Which would be more likely to be eaten? Of course, both of these outcomes will affect weight gained or lost. Slide 10. Okay, in this table, we can see that the same research question can be asked either directionally or non-directionally. In the top row of the under directional research, it predicts that 12th graders will do better than 9th graders. That was going out on a limb. And below that, there is a prediction that community-based long-term care will result in higher scores on social activity scale than those who receive in-home care. Well, that all makes sense, and even not knowing much about those topics, most of us could make pretty well-educated guess about which direction the change will go. So what, you may say? Well, I'll tell you what. When we are able to predict our direction, we are able to choose a single-tailed versus a two-tailed analysis method, which increases our likelihood of significance when we do the numbers. We'll go into that more deeply in the next podcast, however. What makes a good hypothesis? Stated in a declarative form rather than a question. Not what will happen, but what will happen. Defines an expected relationship between variables. Reflects the theory or literature on which it is based. Brief and to the point. And is testable. So it includes variables that can be measured. So we'll get into the nitty-gritty in the next podcast over Chapter 8 from Salkind.